that shows you the different processes that you may be running on the system. So in this instance, when I say PS, it's showing that I'm running a shell program, PC shell. I've also started an X-terminal process, which is what has given me this shell. And then the PS program that I just ran itself got a ID. So the PIDs are process IDs. So just like we learned killing jobs by using the bkill command, if you ended up having a process that stuck, you can kill a specific process. So in this instance, I can kill my X-terminal window by using the kill command. And that should kill, that graphical window went away if you just saw that. So that's one way of killing a process that may be hung. Pardon me? Yes, basically this is sort of the task manager. I mean, that's what we're doing here. So let's see where we are on our jobs. Still pending. So I guess we are not going to get lucky. Are there any questions? Too much stuff, right? Too late in the day. So what I've given you today is essentially an outline of how you're going to use a compute cluster for running jobs. We use BLAT and BLAST as our examples, but if you look at the available modules, I'm assuming a lot of you are going to end up coming to Kildeville Query for doing next generation sequencing analysis. And a number of popular programs that are used for next generation sequencing analysis are available on the cluster. I'll point out some of them here. There's a program called BWA, which is Burroughs-Wheeler Aligner, that is used for aligning short reads to long reference sequences. There are some other useful programs. Bowtie is another aligner. And again, you can find information about the modules by doing module help. There's a popular set of tools that are used along with the BWA program. They are called SAM tools. They are installed on this machine as well. R that I was just talking about is installed on QA and Kildeville. And obviously SAS and Stata and other things are available here as well. So lots of different things you might ultimately find a use for using these two clusters. But always remember to submit jobs only through LSF. Don't get on the wrong side of the system administrators. If you have jobs that are pending for longer than what you consider is sort of normal. So for example, these two jobs should hopefully finish within the next hour or so. By the time you go back to your labs, hopefully you will get an email with the jobs having finished. Let me just show you what you can do. So once you go back, you can go into the netscratch directory, and then I will open a graphical SFTP window in this current directory. So in fact, I think I have a job that I must have previously run. So I have a BLAST file that I had previously generated here. So if you wanted to look at it on your local machine, you're just going to drag it back in the other direction now. So we're going to bring it down from the server to your local desktop. Sometimes you see this error. If that happens, just sort of go back and try doing the transfer again. And down below, you will get a running sort of tally of where that job is. With small things, the jobs complete really quickly. If you are transferring a 10 gigabyte file, you actually can see what speed it's transferring at and how long it's going to take to complete the job in this window down here. So if I go back to my desktop, I should have the blast search that I ran previously. So now I'm able to open this file on my local desktop, and I have 10 things that I had asked for. So it's telling me this was a query I used. I went against the entire nucleotide database, and these links happen to be clickable, so they will actually take you directly to the NCBI listing for the specific hit that you found in your file. So that's one advantage of creating HTML output. And then this is the familiar blast output that you're probably used to seeing on the NCBI site. Remember, I had asked for only 2 alignments to be shown, and that's why I have only 2 alignments that I see, in addition to the 10 listings that I had cut my job off at. If you don't provide those 2 things, it's going to probably give you the default, I believe it's 500 descriptions and 500 alignments by default. So that's what you're going to get if you don't provide a specific number for num alignments and num descriptions. If your lab basically is going to do a lot of sequencing, for example, if you're going to be analyzing thousands of samples, you can talk to me. We'll work with ITS Research Computing to set up an area on the Isilon cluster. We have the storage cluster, so that there will be a space where you can work with large files. Obviously, if you're going to only work with a few sample files, you can always work in NetScratch onion area. Remember to move your results that you want to keep from there. Make a local copy to either your desktop or make a backup copy in the /ms directory. On KillDevil, there is another file system available called Luster. This area is meant for, I believe, using large files. If you're working with large files, this is so there are 2 scratch areas. If you're using very small files, I believe they recommend you use the NETSTR. If you are using large files, then they believe you use this file system, which is particularly high performance, fast file system. Recommendations for use of those 2 file systems are available at the link I have in my handout for using the KillDevil clusters. So I'm pretty sure if you go to Luster, it's probably there isn't one. So you could always make one in Luster and work there. It's Luster SCR. The same deal, so you have to go down the first 2 letters of your onion, and yeah, I have it there. You may already have directories pre-made in Luster. You'll just have to traverse down the right path by using the first 2 letters of your onion. See if you have directories in Luster.